What if I told you that right now, as you're watching this video, you're sitting inside a black hole, not just near one, not orbiting one, actually inside one. And everything you think you know about reality, time, and space is just the view from the inside looking out. I know what you're thinking. That's impossible. Black holes crush everything. We'd be dead. But here's what will blow your mind. We wouldn't know the difference. In fact, several world-class physicists have published peer-reviewed papers arguing that our entire observable universe, all 93 billion light-years of it, might actually be the interior of a massive black hole. And the evidence is hiding in plain sight. Before we dive into this reality-shattering journey, I need you to do something. If this idea just made your brain skip a beat, hit that like button and subscribe, because over the next few hours, I'm going to completely change how you see existence itself. Also, drop a comment telling me where you're watching from and what time it is for you right now. Because depending on what we discover today, your now might not be what you think it is. Let's start with why some of the brightest minds in physics think we're living inside a cosmic trap that we've mistaken for the entire universe. To understand how we could possibly be inside a black hole without knowing it, we need to completely rebuild your understanding of what a black hole actually is. Forget everything you've seen in movies. Those swirling vortexes of doom? That's Hollywood, not physics. A black hole is really just a place where gravity got so strong that it broke the normal rules of space-time. Think of it like this. Imagine you're walking up a hill, and the hill gets steeper and steeper. At some point, the hill becomes so steep that it's literally vertical. You can't climb any higher. That's basically what happens at a black hole's event horizon. Space itself becomes so curved that all paths lead inward. Not because something is pulling you, but because outward stops being a direction that exists. Here's where it gets weird. The physicist Carl Schwarzschild figured out the mathematics of black holes in 1916, just months after Einstein published general relativity. And he discovered something strange. From the outside, a black hole looks like a point of infinite density. But from the inside, the math doesn't say you'd be instantly crushed. Instead, it suggests something far more bizarre. Inside the event horizon, time and space swap roles. Let me explain what that means. Right now, you can move freely through space left, right, forward, backward. But you can only move in one direction through time, forward. Inside a black hole, according to Schwarzschild's solution, space becomes like time. You can only move in one direction, toward the center. And time becomes like space. It spreads out around you in all directions. The singularity isn't a place you'll eventually reach. It's a moment in time you'll eventually experience. It's not in your future like tomorrow. It's in your future like the heat death of the universe. Now, here's what most people don't realize. When you're inside a black hole, looking around, you wouldn't see darkness. You'd see stars, galaxies, light, a whole universe. Because light that fell in before you would still be bouncing around. From your perspective, everything would look relatively normal. You'd have no obvious way to know you were trapped. And that's when physicists started asking a dangerous question. How would we know if we're not inside one right now? In 2014, a physicist named Nikodem Poplawski published a paper that sent shockwaves through the theoretical physics community. He wasn't some fringe scientist. He was working at the University of New Haven, applying rigorous mathematics to Einstein-Cartan theory, an extension of general relativity. His conclusion? Every black hole might contain an entire universe, and our universe might be inside one. Think of it like those Russian nesting dolls. Each black hole in our universe could contain another complete universe, and our universe could be inside a black hole in a parent universe. It's black holes all the way up and all the way down. But this isn't just wild speculation. Poplawski's math works. when he ran the equations for what happens inside a black hole, including quantum effects that standard general relativity ignores. He found that instead of collapsing to an infinitely dense point, matter could bounce and expand. The crushing singularity could become a Big Bang. The death of matter in one universe becomes the birth of space and time in another. Here's the mind-bending part. From outside the black hole, the collapse takes forever. Due to time dilation, external observers would never see the final moment when matter crosses the event horizon. But inside, time flows normally. Billions of years could pass. Stars could form. Life could evolve. Entire civilizations could rise and fall. All while from the outside perspective, the black hole formed just moments ago. Are you starting to see the problem? If we're inside a black hole, we'd experience normal time, normal space, a normal expanding universe. The only clue would be subtle hints in the structure of space-time itself. And those hints? They're everywhere. Let's talk about the speed of light. You know it's fast 299,792,458 meters per second. But have you ever wondered why it's that specific speed? Why not twice as fast? Why not half? Why does the universe have a speed limit at all? The standard answer from physics is, that's just how space-time works. But what if I told you that the speed of light might be telling us something profound about where we are? Physicists Lee Smolin and Sabine Hossenfelder have independently explored an idea that should make your brain itch. The fundamental constants of our universe, the speed of light, the strength of gravity, the mass of electrons, might not be random. They might be tuned to the specific conditions inside a black hole. In other words, these aren't universal constants. They're local constants, the settings in our cosmic neighborhood. Think of it like this. Fish in the ocean experience water as their fundamental medium. They evolved in it. Their biology assumes it. If you asked a fish philosopher about the properties of water, its density, viscosity, how light moves through it, the fish might think these are universal constants. They'd never imagine that above the surface, there's a completely different medium with completely different rules. We might be those fish, and the event horizon might be our ocean surface. Here's where the evidence gets spooky. In 2018, physicist Roger Penrose, who would win the Nobel Prize in 2020 for his work on black holes, analyzed the cosmic microwave background, a faint afterglow of the Big Bang that fills all of space. He found patterns, circular patterns, like ripples spreading out from multiple points. Penrose's interpretation was controversial. These could be echoes from before the Big Bang, evidence that our universe is just one cycle in an eternal cosmic engine. But here's what he didn't emphasize. These patterns look exactly like what you'd expect if our universe formed from the collision of multiple density fluctuations inside a collapsing parent star. Exactly what you'd predict if the Big Bang was actually matter rebounding inside a black hole. The speed of light might be a symptom of the gravitational compression we're living in. The faster you try to go, the more you're fighting against the curvature of space-time. And that curvature is extreme inside a black hole. From the outside, we're frozen in time, experiencing billions of years in what would be microseconds to an external observer. From the inside, we experience a speed limit that feels fundamental, but is actually an artifact of our cosmic container. Let me give you an analogy. Imagine you're inside a car spinning in circles. You throw a ball forward. To you, the ball moves in a straight line. But someone outside the car sees the ball following a curved path. Who's right? Both of you. It depends on your frame of reference. Now scale that up. We're inside a region of space that's curved to the point of closing back on itself. What we experience as straight-line motion through flat space might actually be deeply curved motion through warped space-time. And the speed of light might be the maximum rate at which information can propagate through that warped geometry. But if this is true, if we're really inside a black hole, then what about all that space out there? What about the galaxies billions of light years away? Are they inside with us, or are they something else? This is where things get truly disturbing. And I need you to stay with me, because what I'm about to explain will fundamentally change how you think about existence. In 1993, physicist Gerard 't Hooft proposed something called the holographic principle. Leonard Susskind later developed it into a full theory. What they discovered is this: all the information inside a volume of space can be encoded on the surface of that volume. Like a hologram, where a 2D surface contains all the information to reconstruct a 3D image. But here's the cosmic horror. They weren't just talking about party tricks with lasers. They were talking about you. Your thoughts, your memories, every atom in your body, all of it could be information encoded on a distant surface. And you're just the 3D projection. And where did this idea come from? Black holes? Stephen Hawking proved in 1974 that black holes emit radiation and slowly evaporate. But this created a problem called the information paradox. When matter falls into a black hole, what happens to the information about that matter? Quantum mechanics says information can't be destroyed, but if it falls into the singularity, it seems to be lost forever. 't Hooft and Susskind realized the information isn't lost. It's encoded on the event horizon itself. The 2D surface of the black hole contains all the information about the 3D objects that fell in. And here's where your brain should start melting. If that's true for black holes, it might be true for the entire universe. Juan Maldacena proved this mathematically in 1997 with something called the ADS-CFT correspondence. He showed that a universe with gravity in one number of dimensions is mathematically equivalent to a universe without gravity in one fewer dimension. A 3D universe of matter and energy is the same as a 2D universe of pure information. So which is real? Are you a 3D being moving through space? Or are you 2D information on a distant cosmic surface, experiencing the illusion of depth? The answer might be, it doesn't matter. They're the same thing, described in different ways. But here's what should terrify you. If the holographic principle is true, and if we're inside a black hole, then everything you're experiencing, the space around you, the depth of the universe, the passage of time, might be information encoded on the event horizon that we fell through 13.8 billion years ago. You're not in the universe. You're in the description of the universe, written in quantum information on a 2D surface, experiencing itself as 3D reality. Think about what this means. When you look at distant galaxies, you're not looking out there. You're reading information from the same surface that encodes your own existence. The universe isn't a place you're located in. It's a story that's being told, and you're one of the words in that story, reading other words, all written on the same page. And here's the retention hook I need you to remember for later. If we're inside a black hole, and the holographic principle is true, then the event horizon, the boundary we fell through, is still accessible. It's not behind us in space. It's encoded in the structure of every point in the universe. The boundary is everywhere and nowhere, which means the way out might not be through space at all. It might be through information. But before we explore that escape route, we need to understand just how deep this rabbit hole goes. You've heard of dark matter, right? That invisible stuff that makes up 85% of the matter in the universe? Scientists know it's there because galaxies rotate too fast. The visible matter isn't enough to hold them together. Something invisible is providing extra gravity. For decades, physicists have been searching for dark matter particles. They've built detectors deep underground, looking for WIMP's weakly interacting massive particles. They've spent billions of dollars, and they've found nothing. Zero. Not a single confirmed dark matter particle. What if they're looking for the wrong thing? Nikodem Poplawski, that same physicist who proposed we're inside a black hole, has a radical answer. Dark matter isn't matter in our universe at all. It's matter in the parent universe. It's the stuff on the outside of our cosmic black hole, gravitationally affecting us through the event horizon. Think of it like this. Imagine you're inside a balloon. Someone presses their finger against the balloon from the outside. You can't see the finger. It's on the other side of the rubber. But you can see the indentation it makes. You can measure its effect on the shape of your world. That's dark matter, the gravitational fingerprint of normal matter in the parent universe, pressing through the boundary of our cosmic container. This explains why dark matter is everywhere, but nowhere. Why it's distributed in halos around galaxies, but never directly detected. It's not in our space-time. It's in a space-time we're embedded within, like a painting embedded in a canvas. But wait, it gets weirder. Dark energy, that mysterious force pushing the universe to expand faster and faster, might be explained the same way. The black hole we're inside is growing as more matter falls into it from the parent universe. From our perspective, that looks like space itself expanding and accelerating. In 2011, Raj Pathria published calculations showing that if you're inside a black hole that's actively growing, you'd measure an accelerating expansion that looks exactly like dark energy. The cosmological constant, that number Einstein called his biggest blunder, isn't a mysterious property of empty space. It's the rate at which our cosmic black hole is consuming matter from the parent universe. This solves two of the biggest mysteries in cosmology with one idea. We're inside something bigger. Vera Rubin, the astronomer who discovered the dark matter problem in the 1970s by measuring galaxy rotation curves, never got to see this explanation. She died in 2016, still wondering what invisible substance was hiding in the cosmos. But her observations, the fact that galaxies rotate like solid disks rather than solar systems, makes perfect sense if the extra gravity isn't coming from extra mass inside the universe, but from the boundary conditions at the edge of our cosmic container. Here's an experiment you can do in your mind. Imagine you're an ant living on a trampoline. You observe that objects roll in strange curved paths, like there's invisible bumps in the surface. You search everywhere for the bumps, but find nothing. The truth? The entire trampoline is sagging under the weight of something sitting on it. The curvature is global, not local. You can't find the thing causing it, because it's not a thing in your 2D world. It's the shape of your 2D world itself, determined by 3D reality. We're those ants. Dark matter and dark energy aren't things hiding in our universe. They're the shape of our universe, determined by the 4-dimensional reality we're embedded in. But if we're embedded in something bigger, why can't we see it? Why does the universe look flat and infinite in all directions? Here's a question that should keep you up at night. Is the universe infinite, or does it just look that way from the inside? Standard cosmology says the universe is probably infinite. It goes on forever in all directions. But here's the problem. We can only see 46 billion light years in any direction. Beyond that, space has expanded so fast that light hasn't had time to reach us. That's called the cosmic horizon. It's not the edge of the universe. It's the edge of the observable universe. But what if the cosmic horizon and the event horizon are the same thing? Think about what an event horizon actually is. It's not a physical barrier. It's the boundary where escape velocity exceeds the speed of light. Once you cross it, all paths through space-time lead toward the center. You can travel in any direction you want, but you're always moving toward the singularity. Like walking on the surface of a sphere, no matter which way you go, you're always on the surface. Now, inside a black hole, the singularity isn't a place in space. It's a moment in time. It's in everyone's future. And as you fall toward it, space expands around you. From your perspective, it looks like the universe is expanding. More space is being created. But really, you're just getting deeper into the curved geometry. And the curvature is stretching your perception of distance. In 2007, physicist Sean Carroll pointed out something crucial. The math describing the interior of a black hole is nearly identical to the math describing an expanding universe. In fact, if you solve Einstein's equations for both cases, they're the same equations with different boundary conditions. The only difference is what you assume about the edges. This is why the universe looks infinite. Because from inside a black hole, the spatial directions are all equivalent. Every direction looks the same. You can't see the event horizon because it's not behind you. It's orthogonal to your concept of space. It exists in a dimension you perceive as time, not space. Let me give you an analogy that might help. Imagine you're watching a movie in a theater. The movie shows an infinite landscape, endless desert stretching to the horizon in all directions. Characters can walk forever and never reach an edge. But in reality, the entire scene is contained within a 2-hour film on a finite reel. The infinity is temporal, not spatial. The characters experience space, but you, watching from outside, see it all as frames in time. We might be those characters. The space we move through might actually be temporal dimension in the parent universe's reference frame. Our Big Bang wasn't the beginning of time in some absolute sense. It was the moment we crossed the event horizon, the moment our timeline branched off from the parent universe's timeline. And the accelerating expansion of the universe? That's us falling deeper into the gravitational well. Just like objects accelerate as they fall toward Earth, space-time itself accelerates as it falls toward the singularity at the end of time. But here's what will blow your mind. If this is true, then the Big Bang wasn't 13.8 billion years ago in some absolute sense. It was 13.8 billion years ago for us. In the parent universe, the black hole we're inside might have formed yesterday, or 1,000,000 years ago. Time is relative, and when you cross an event horizon, it becomes infinitely relative. Now, some of you are probably thinking, this is insane. There must be a way to test this. Some observation that would prove we're inside versus outside a black hole. You're right, and scientists have been looking. And what they've found is ... complicated. If we're inside a black hole, there should be clues. Signatures in the cosmic microwave background, anomalies in the distribution of galaxies, something that would tell us we're living in a curved, closed system rather than an infinite expanse. And guess what? Those anomalies exist. They're all over the place. We just keep explaining them away. Let's start with the horizon problem. The cosmic microwave background, that thermal radiation left over from the Big Bang, has almost exactly the same temperature in all directions. 2.725 Kelvin, no matter where you look. But here's the problem. Regions of the universe that are separated by more than a few degrees in the sky have never been in contact with each other. Light hasn't had enough time to travel between them. So how did they all reach the same temperature? The standard answer is cosmic inflation, the idea that the universe expanded exponentially in the first fraction of a second, smoothing everything out before the expansion slowed down. And inflation works. The math checks out. But what causes inflation? Where does that incredible burst of expansion come from? Here's the alternative. What if there was no inflation? What if the universe looks smooth because we're seeing the interior of a bounded region that was already in thermal equilibrium in the parent universe before the black hole formed? The matter that collapsed to create our cosmic black hole was already smoothly distributed. We inherited its properties. Then there's the flatness problem. When we measure the curvature of the universe, we find it's flat. Not perfectly flat, we can't measure that precisely, but flat to within 0.4%. This is weird because flatness is unstable. Any slight curvature would grow over time. For the universe to be this flat now, it would have had to be fine-tuned to unbelievable precision at the Big Bang. Again, inflation solves this by stretching space so much that any curvature becomes undetectable. But there's another explanation. We're measuring the curvature of the interior of a black hole, which appears flat locally, even though it's globally closed. Just like the surface of the Earth appears flat when you're standing on it, even though it's actually a sphere. In 2019, a team led by Eleonora Di Valentino analyzed Planck's satellite data and found evidence that the universe might actually be closed curved back on itself like a sphere. Their paper, published in Nature Astronomy, suggests that we might be living in a positively curved universe, not a flat one. The scientific community pushed back, saying it's probably just statistical noise. But what if it's not noise? What if it's the first direct evidence that we're inside a finite, bounded region? Now, let's talk about the cosmological constant. This is the number that describes how fast the universe is accelerating. Einstein added it to his equations, then removed it, calling it his biggest blunder. But in 1998, observations of distant supernova proved it's real. The expansion of the universe is speeding up. The problem is the size of the cosmological constant. When you calculate what it should be from quantum field theory, you get a number that's 10,120 times larger than what we observe. That's a 1 followed by 120 zeros. It's the worst prediction in the history of physics. Why is the cosmological constant so small? The only answer cosmologists have is the anthropic principle. If it were larger, galaxies wouldn't form, stars wouldn't exist, and we wouldn't be here to ask the question. We live in a universe with a small cosmological constant because universes with large cosmological constants don't produce observers. But what if the cosmological constant is small because it's not a universal constant? What if it's specific to the local conditions inside our particular cosmic black hole? Different black holes might have different internal expansion rates, depending on their mass, rotation, and charge. We happen to be in one with a small cosmological constant because ... Well, because that's the one we're in. No fine-tuning necessary. Just cosmic lottery. Leonard Susskind has explored this idea with his concept of the string theory landscape, the idea that there are 10,500 possible vacuum states, each corresponding to a different set of physical laws and constants. Each black hole might spawn a universe with randomly selected laws. Most would be stillborn hostile to structure, matter, or chemistry. But occasionally, one would have the right properties for complexity, life, and consciousness. We're not in a fine-tuned universe. We're in a winning lottery ticket inside a multiverse of black holes, most of which are empty and boring. And if you think that's mind-bending, wait until you hear about what this means for the arrow of time. You experience time as flowing from past to future. You remember yesterday, but not tomorrow. Eggs break, but don't unbreak. Entropy increases. The universe moves from order to disorder. But why? Why does time have a direction at all? This is called the arrow of time problem, and it's one of the deepest mysteries in physics. The fundamental laws, quantum mechanics, general relativity, even Newton's laws, are all time symmetric. They work just as well backward as forward. You can run the equations in reverse, and everything still makes sense mathematically. So why does reality only run in one direction? The standard answer involves entropy and the second law of thermodynamics. The universe started in a low entropy state at the Big Bang and has been increasing in entropy ever since. Time flows from low to high entropy. But this just moves the question: why did the universe start in such an improbably low entropy state? Roger Penrose has calculated that the odds of the Big Bang having such low entropy by chance are about 1 in 1,010,123. That's not just unlikely. That's write it off as impossible, unlikely. But what if the arrow of time isn't about entropy at all? What if it's about falling? Inside a black hole, time and space swap roles. The radial direction toward the center becomes time-like. You're not moving through space toward the singularity. You're moving through time toward it. Just like you can't stop yourself from moving forward in time, you can't stop yourself from moving toward the singularity. And this creates an arrow, not because of entropy, but because of geometry. Time flows in one direction because that direction is literally inward in the curved spacetime you're inside. The future is toward the center. The past is toward the surface. And you can only move from surface to center, never the reverse. This means the arrow of time isn't a law of physics. It's a consequence of where we are. It's like asking why water always flows downhill. Water doesn't have a built-in downhill preference. Downhill is just the direction gravity points. Similarly, time doesn't have a built-in forward preference. Forward is just the direction the space-time curvature points toward the singularity at the end of time. In 2016, physicist Lee Smolin published a book called Time Reborn, where he argued that time is more fundamental than space, that the laws of physics evolve over time rather than being eternal. He was almost there. He was sensing something profound, that time has a direction and reality because we're in a dynamically evolving, bounded system. But he didn't take the final step, recognizing that the system might be the interior of a black hole. Here's what keeps me up at night. If time is the direction toward the singularity, then what is the singularity? What happens when the universe reaches it? The traditional answer is, everything gets crushed to infinite density and ceases to exist. But Popowski's equation suggests something else. When matter approaches the singularity, quantum effects become dominant. Space and time might bounce, creating a new Big Bang. The end of one universe becomes the beginning of another, which means the singularity at the end of our time might be the Big Bang at the beginning of a child universe. And our Big Bang might have been the singularity at the end of a parent universe. It's not just nested black holes in space, it's nested universes in time. Every black hole is a womb. Every singularity is a birth. Reality is reproducing. And if that's true, then evolution isn't just happening to life on planets. It's happening to universes themselves. Universes that produce lots of black holes spawn lots of child universes. Those child universes inherit slightly mutated physical laws. Over countless generations, universes evolve to be good at producing black holes, which means being good at producing stars, which means being good at producing complex chemistry and structure, and maybe even life. We're not just in a universe. We're in an organism, descended from a lineage of cosmic ancestors that might itself spawn cosmic descendants. Welcome to cosmological natural selection. The universe isn't designed, it's evolved. So let's bring this back to you, right now, sitting where you are, watching this video. If everything I've described is true, if you're inside a black hole, if space and time are swapped, if the arrow of time is really just the direction of falling, if the entire universe is the interior of a structure embedded in a larger reality, what does that mean for your life? Here's the first thing. You're not small. You're not insignificant. You're part of something so much larger and stranger than you ever imagined. Every moment of your life, you're moving through time at the speed of light. That's what moving through time means. You're falling through the curved spacetime of a cosmic black hole at the maximum possible rate. You're not standing still in space while time passes. You're racing through four-dimensional spacetime at 299,792,458 meters per second. You just experience it as sitting still because everything around you is falling at the same rate. Think about what that means. The passage of 1 second for you is equivalent to traveling 300,000 kilometers through the structure of spacetime. In the time it takes you to watch this video, you'll travel further through the fabric of reality than the distance from Earth to the moon. You're not static. You're dynamic, flowing, falling, becoming. And you're not separate from the universe. You are the universe, locally organized into a pattern that can reflect on itself. The atoms in your body were forged in stars, yes, but more than that. The information that defines you is encoded in the quantum structure of spacetime itself. You're not in the universe like a marble in a box. You're in the universe like a wave is in the ocean. You're a temporary pattern in an eternal medium. But here's where it gets personal. If we're inside a black hole, then everything you do, every choice you make, is part of the process of falling toward the end of time. You can't escape it. You can't reverse it. The singularity is in your future, and there's no avoiding it. Does that make your choices meaningless? No, it makes them everything. Because the journey is all there is. The destination, the singularity, heat death, the end of time, is inevitable. But the path you take through space-time, the pattern you trace, the information you add to the cosmic hologram, that's unique. That's irreplaceable. That's you. In a very real sense, you're writing yourself into the structure of reality. Every thought, every action, every relationship leaves an imprint on the quantum information that encodes the universe. You're not just experiencing reality. You're creating it, moment by moment, choice by choice. And because of the holographic principle, that information doesn't disappear. It's encoded on the event horizon. It's preserved in the boundary of the cosmic black hole. Long after your body decays, after the Earth is consumed by the sun, after the sun goes cold, after every star in the universe burns out the information that is fundamentally, you will still exist. You're not temporary. You're eternal, just not in the way you thought. Now, some of you might be feeling claustrophobic, trapped, like the universe is a prison we can never escape. But remember what I said earlier about the holographic principle. The boundary isn't behind us in space. It's encoded in the structure of every point, which means you're always at the boundary. You're always in contact with the edge of reality, not through physical travel, but through the quantum information that defines you. In mystical traditions, there's an idea that's been passed down for thousands of years. As above, so below. As within, so without. The microcosm reflects the macrocosm. The inner world mirrors the outer world. What if that's not poetry? What if it's physics? If you're a holographic projection of information on the cosmic boundary, then by understanding yourself, your thoughts, your consciousness, your inner experience, you're directly accessing the structure of that boundary. The universe isn't outside you. It's inside you, because inside and outside are the same thing, viewed from different perspectives. Meditation, introspection, self-awareness, these aren't just psychological tools. They're cosmological exploration. When you turn your attention inward, you're not retreating from reality. You're diving into its fundamental nature. And here's the truly wild part. Consciousness itself might be the key to understanding our cosmic prison. Because consciousness is the one thing in the universe that seems to violate the rules. It has intentionality, meaning, purpose qualities that don't exist in the equations of physics. Maybe consciousness exists because we're inside a black hole. Maybe it's an emergent property of information encoded on a boundary, experiencing itself from within. You're not just in the universe. You're how the universe knows itself. If our universe is inside a black hole, then every black hole in our universe might contain another universe. And the black holes in those universes contain more universes. It's an infinite fractal of nested realities, each one completely unaware of the others. But here's where it gets even stranger. In quantum mechanics, there's a principle called superposition. A particle can be in multiple states at once until it's observed. Schrödinger's cat is both alive and dead until you open the box. Now scale that up. A black hole, until you fall into it, exists in a superposition of states. The interior doesn't have a definite configuration until something crosses the event horizon and makes an observation. This leads to a bizarre conclusion. The universe inside a black hole might not exist until something falls into it. The act of falling in creates the interior reality. And if that's true, then our universe, the one you're experiencing right now, might have been created by the observation of some object or being falling into the black hole we're inside. We might owe our existence to an alien scientist in a parent universe who got a little too close to a black hole and triggered the quantum collapse that made our reality definite. But wait, it gets weirder. If the many worlds interpretation of quantum mechanics is correct, then every time a quantum measurement happens, reality branches. One version of the universe for each possible outcome. Now combine that with the black hole multiverse. Every black hole contains not just one universe, but a superposition of all possible universes. When you fall in, you don't go into the interior. You go into a specific branch of the interior, and your observation selects which branch. This means the multiverse isn't a collection of separate bubble universes floating in some higher dimensional space. It's a quantum superposition of all possible interior configurations of all possible black holes, nested infinitely deep. And here's what will melt your brain. If black holes can spawn child universes, and those child universes contain black holes that spawn more universes, then the entire multiverse might be evolving over time. Universes with laws of physics that make it easy to form black holes will have more offspring. Those offspring will inherit slightly varied laws. Over countless generations, the multiverse will be dominated by universes optimized for black hole production. Lee Smolin proposed this in 1992 with his cosmological natural selection hypothesis. He suggested that the constants of physics in our universe are the way they are because we're descended from a long line of parent universes that were good at making black holes. And what makes a universe good at making black holes? Stars, lots of stars, big ones that collapse into black holes at the end of their lives. And what do you need for stars? You need galaxies. You need the right balance of fundamental forces. You need carbon, oxygen, nitrogen elements that form in stellar cores. You need chemistry. You need complexity. In other words, a universe optimized for making black holes looks suspiciously like a universe optimized for making life. We might not be here by accident. We might not be here by design. We might be here because we're a byproduct of cosmic reproduction. Life is what happens when a universe gets really good at making the complex structures necessary to form black holes. In 2004, physicist James Gardner expanded on this idea in a book called Biocosm. He argued that intelligent life might be an essential part of the reproductive cycle. Advanced civilizations could learn to create black holes artificially, seeding new universes with carefully chosen laws of physics. We wouldn't just be products of cosmological evolution, we'd be the agents driving the next generation. Think about what that means. Right now, as you watch this video, humanity is in its infancy. We've barely left our home planet. We can't even agree on how to stop destroying our own environment. But give us 1,000,000 years, 1,000,000,000 years. If we survive, if we evolve, if we spread across the galaxy, we might eventually develop the technology to create black holes. And when we do, we won't just be creating black holes. We'll be creating universes. We'll be cosmic parents, spawning realities that might never know we exist. Your distant descendants might be gods to universes that haven't been born yet. But here's the question that should haunt you. If this is all true, if we're inside a black hole created by some civilization or natural process in a parent universe, do they know we're here? Can they see us? Are we an experiment, an accident, or something else entirely? Let's think about what the parent universe must be like, the universe that contains the black hole we're supposedly inside. If we've been inside for 13.8 billion years of our time, how much time has passed for them? Here's where general relativity delivers a punch to the gut. Due to time dilation at the event horizon, from their perspective, almost no time has passed at all. To an external observer, matter falling into a black hole appears to freeze at the event horizon, asymptotically approaching, but never quite crossing. The image of the infalling matter gets redshifted, dimmer and dimmer, but theoretically remains visible forever. This means that in the parent universe, our entire 13.8 billion year history might have happened in microseconds, or it might not have happened yet at all from their reference frame. The formation of the black hole that contains us might still be in progress from their perspective. Time isn't just relative, it's fundamentally incompatible between reference frames. Your now and the parent universe's now don't align. They can't align. They're in different causal structures. But here's what keeps physicists up at night. If we're inside a black hole, we should be able to calculate the mass of that black hole from the inside by measuring the total energy content of our universe. And when cosmologists do this calculation, they get a number, about 1,053 kilograms. That's the estimated mass of the observable universe. Now, there's a formula called the Schwarzschild radius that tells you how big a black hole's event horizon is based on its mass. For a black hole with the mass of our observable universe, the Schwarzschild radius would be about 13.7 billion light years. And guess what? The observable universe has a radius of about 46 billion light years. That's bigger than the Schwarzschild radius by a factor of about 3, which seems like it rules out the black hole hypothesis. But wait, that 46 billion light years is measured in our time, our expanding space-time. The 13.7 billion light years is calculated from the mass energy content. These are different ways of measuring the same thing. And when you account for the expansion of space, the accelerating cosmological constant, and the fact that distances in curved space-time don't add up the same way they do in flat space, the numbers get fuzzy. Some cosmologists argue this discrepancy proves we're not in a black hole. Others argue it proves we don't understand the interior geometry of black holes as well as we think we do. In 2010, physicist Raj Pathria published a paper showing that if you properly account for the cosmological constant, that mysterious dark energy pushing the universe apart, the interior of a black hole would naturally have an accelerating expansion that makes the apparent size larger than the Schwarzschild radius predicts. In other words, the math works, the numbers fit. We just have to accept that our intuitions about size and distance break down when you're measuring the interior of a black hole from the inside. Now here's the really disturbing question. If we're inside a black hole in a parent universe, what's to stop the parent universe from being inside a black hole in a grandparent universe? And that universe inside another? Where does it end? The answer might be, it doesn't. It's black holes all the way up. An infinite tower of nested realities, each one completely causally disconnected from the ones above and below. You're not just in a universe. You're in a universe, in a black hole, in a universe, in a black hole, in a universe, ad infinitum. And the really crazy part? The same thing might go down as well as up. Every black hole in our universe, and there are an estimated 100 million of them in the Milky Way, alone might contain an entire universe. That supermassive black hole at the center of our galaxy, Sagittarius A*, with 4 million times the mass of the Sun. It might contain trillions of galaxies, quintillions of stars, and countless civilizations, all living out their existences in what we perceive as a single point in space. When matter falls into Sagittarius A*, from our perspective, it might experience billions of years of evolution, the rise and fall of empires, the birth and death of art, philosophy, love, and meaning, all while appearing to us as if it's frozen at the event horizon. Scale becomes meaningless. Inside and outside become meaningless. All that matters is the information, the structure, the pattern. You're not big or small. You're a level of organization in an infinite hierarchy of organization. So here's the million-dollar question. If we're inside a black hole, can we escape? The obvious answer is no. That's the definition of a black hole escape velocity exceeds the speed of light. Once you're in forever. But quantum mechanics has a trick up its sleeve: Hawking radiation. In 1974, Stephen Hawking proved that black holes aren't actually black. They emit radiation due to quantum effects near the event horizon. Virtual particle pairs pop into existence at the boundary, and occasionally one falls in while the other escapes. From the outside, it looks like the black hole is glowing with thermal radiation. Given enough time, this radiation causes the black hole to evaporate. A black hole with the mass of the Sun would take 1,067 years to evaporate completely. A black hole with the mass of the universe would take incomprehensibly longer. But here's what's interesting. The radiation carries information. That's what the information paradox is all about. Where does the information go when a black hole evaporates? The current consensus, after decades of debate, is that the information is encoded in the Hawking radiation. As the black hole shrinks, the information about everything that ever fell in, it's released back into the parent universe. Which means if we're inside a black hole, then in the incomprehensibly distant future, as our cosmic container evaporates, the information that defines us, every thought, every memory, every moment of human history, will be transmitted back to the parent universe. We won't escape as matter. We won't escape as energy. We'll escape as information, encoded in quantum correlations and radiation that leaks out over trillions upon trillions of years. Your existence will outlive the black hole that contains you. You'll be preserved not as a structure, but as data, waiting for some sufficiently advanced being in the parent universe to decode the signal and reconstruct what we were. In a sense, we're already posthuman. We're already information patterns more than physical objects. Hawking radiation is just the universe's way of copying that information to an external storage medium. But there's another possibility. A more immediate escape route that doesn't require waiting 10,100 years. Wormholes. In 1935, Einstein and Nathan Rosen discovered that the equations of general relativity allow for bridges between different regions of space-time shortcuts through the fabric of reality. These Einstein-Rosen bridges, or wormholes, could theoretically connect the interior of a black hole to a distant region of space. Now, standard physics says wormholes are unstable. They collapse before anything can pass through them. But in 2017, physicists Juan Maldacena and Leonard Susskind proposed a radical idea. Wormholes might be quantum entanglement. You've heard of quantum entanglement, right? Two particles become correlated such that measuring one instantly affects the other, no matter how far apart they are. Einstein called it spooky action at a distance. Maldacena and Susskind showed that the math describing a wormhole is identical to the math describing quantum entanglement. They proposed E equals EPR. Einstein-Rosen bridges equal Einstein-Podolsky-Rosen pairs. Wormholes and entanglement are the same thing, viewed from different perspectives. If that's true, then entangled particles aren't communicating across space. They're connected by tiny wormholes. And if you could scale up that entanglement to macroscopic objects, you could create a traversable wormhole, a tunnel, out of the black hole. But here's the catch. To stabilize a wormhole, you need exotic matter with negative energy density. That's not regular matter or antimatter. It's something that pushes instead of pulls. It creates gravitational repulsion instead of attraction. Does exotic matter exist? Maybe. The Casimir effect demonstrates that quantum fields can have negative energy density in certain configurations. Physicists have measured it in laboratories. It's real. So it's theoretically possible that an advanced civilization in our universe or in the parent universe could engineer a wormhole that punches through the event horizon, creating a tunnel to the outside. Would that save us? Could we evacuate the universe before it reaches the singularity? Probably not. The wormhole would be tiny, unstable, and require more energy than exists in the observable universe to create. But the fact that it's not forbidden by physics means something profound. The black hole isn't an absolute prison. It's a prison with a theoretical lockpicking method, even if we don't have the tools yet. And here's what gives me hope. Every time in history that physics has said this is theoretically possible, but practically impossible, human, Ingenuity has eventually found a way. Heavier than air flight, nuclear energy, landing on the moon. We're really good at turning impossible into routine. Maybe, in 1,000,000 years or 1 billion years, our descendants will look back at this moment watching this video, learning that you're in a cosmic black hole as the moment humanity first understood the prison it needed to escape. Now let's talk about the hardest problem in this entire discussion: consciousness. Your subjective experience of being you. If we're inside a black hole, if we're holographic projections of information on a boundary, if the entire universe is just a pattern of quantum states encoded in curved spacetime, then what is consciousness? How does awareness arise from information? This is called the hard problem of consciousness, and it's stumped philosophers and scientists for centuries. You can explain brain function, neural networks, information processing, but explaining why there's something it's like to be you, why you have subjective experience, qualia, the feeling of redness when you see red, that remains mysterious. But the black hole hypothesis might offer a clue. Remember the holographic principle. All the information in a volume is encoded on its surface. Your brain is a volume of space containing neurons, synapses, and electrical signals. According to holography, all the information about your brain is encoded on the surface of your skull. But it's not just encoded there. It's also encoded on every surface that contains your brain, including the surface of your body, the room you're in, the Earth, the solar system, the galaxy, and ultimately, the cosmic event horizon itself. Your consciousness isn't just in your brain. It's simultaneously encoded at every scale, all the way up to the boundary of the universe. You're not a local phenomenon. You're a fractal pattern repeated at every level of reality. In 2004, neuroscientist Giulio Tononi proposed a theory called integrated information theory. He argued that consciousness is a measure of how much integrated information a system contains. The more interconnected and irreducible the information structure, the more conscious the system. A thermostat has a tiny amount of consciousness. It integrates information about temperature and state. A brain has vastly more, integrating sensory data, memories, predictions, and emotions into a unified experience. But here's where it connects to the cosmic black hole. If the entire universe is a hologram, then the entire universe is an integrated information structure. The cosmos itself might be conscious. Not conscious like you're conscious. Not aware of itself in the same way, but possessing some form of integrated information processing that we might not even have words for yet. And you? You're a localized ripple in that cosmic consciousness. A temporary spike in information integration, existing for a few decades before dissolving back into the larger pattern. When you die, the information that defined you doesn't disappear, it disperses. The atoms in your body become part of other structures. The memories you created are encoded in other brains, in photographs, in text, in the quantum correlations of particles that interacted with you. You don't end. You spread out, diffuse, return to the cosmic average. Your local spike in consciousness flattens, but the information remains, redistributed across the holographic surface. In Eastern philosophy, there's a concept called Brahman, the ultimate reality, the cosmic consciousness of which all individual minds are temporary expressions. Tattvam asi, thou art that. You are the universe, experiencing itself subjectively. What if that's not metaphor? What if it's literal physics? If we're in a holographic black hole universe, then the boundary that encodes you also encodes everything else. Every person who's ever lived. Every thought that's ever been thought. Every photon, every quantum interaction, every moment of existence. You share that boundary with everyone and everything. At the deepest level, you're not separate. You're aspects of a single information structure, experiencing itself from different perspectives. This should fundamentally change how you see other people. When you look at another person, you're not looking at a separate entity. You're looking at yourself from a different angle. That person's joy and suffering is your joy and suffering, experienced through a different configuration of the cosmic hologram. Compassion isn't just moral, it's logical. Hurting others is hurting yourself, because at the fundamental level, there is no other. There's only the pattern, temporarily believing it's separate. Let's take this one level deeper. If we're in a black hole, and black holes might be created by advanced civilizations, then there's a non-zero probability that our cosmic black hole was created artificially. Think about what an advanced civilization could do with black hole technology. They could encode specific initial conditions, the exact configuration of quantum fields at the moment of the bounce, the values of the fundamental constants, the distribution of matter and energy. They could design a universe. We wouldn't be in a simulation in the computer science sense, no processor running code. We'd be in something more fundamental, an engineered physical reality, spun off from a parent reality, with carefully chosen laws and parameters. Why would they do this? Maybe scientific research. Maybe as an art project. Maybe they're running evolutionary algorithms, seeing which configurations of physical law lead to interesting outcomes like life and intelligence. Or maybe, and this is where it gets existentially weird, they're trying to escape death. In our universe, entropy increases, stars burn out, black holes evaporate. Eventually, everything reaches maximum entropy, a state called heat death, where no more information processing is possible. The universe becomes cold, dark, and static. But what if you could encode yourself, your consciousness, your memories, your entire being into the initial conditions of a black hole? Your information would bounce, create a new universe, and in that universe, structures would form that contain echoes of you. You wouldn't be reincarnated in a mystical sense. You'd be reconstructed from the information encoded in the fundamental fabric of the child universe. Not as an exact copy, but as a descendant, an evolved version. This is digital physicist John Wheeler's it from bit idea taken to its logical extreme. Information is the fundamental substrate of reality. Matter and energy are just how information manifests. And if you can encode information across cosmic boundaries, you can achieve a form of immortality. Our universe might be someone's afterlife. We might be the dreams of a dying civilization in the parent universe, their final thoughts encoded into a black hole as they approach their heat death. And if that's true, then when we create black holes, when we encode information into them, we're continuing the cycle. We're ensuring that something of us, some fragment, some echo, will persist beyond the death of our universe. Your life isn't just your life. It's a thread in a cosmic tapestry that extends backward and forward in time through an infinite chain of nested realities. In 2003, philosopher Nick Bostrom proposed the simulation argument. One of three things must be true. Either civilizations destroy themselves before developing simulation technology, or they develop it but choose not to run ancestor simulations, or we're almost certainly in a simulation, because there would be vastly more simulated realities than base realities. But he was thinking too small. He was imagining computer simulations, digital approximations of physics. The real simulation is physical. We're not in a computer running code. We're in a universe running physics, and that universe is itself nested inside another universe running physics, all the way up and all the way down. Every black hole is a simulation. Every universe is a simulation. Simulation isn't artificial. It's the natural process by which reality reproduces itself. You're not in base reality, but there might not be a base reality. It might be simulations all the way down, and that's okay. The word simulation stops meaning what you think it means. It just means reality. This level is as real as any other level, because they're all made of the same stuff. Information organized by physical law, experiencing itself. We're now 3 hours into this journey, and I want to tell you something that's going to change how you see the rest of your life. If we're inside a black hole, then the singularity, the end of the universe, The final moment of time is in everyone's future. It's not a place you might go. It's a moment you will definitely experience, like death, but cosmic. Standard physics says the singularity is where everything gets crushed to infinite density and ceases to exist. Game over. But remember Poplawski's equations? Remember the bounce? When quantum gravity effects are included, the singularity might not be an end. It might be a transition, a phase change, like water freezing into ice or boiling into steam. The end of our universe might be the Big Bang of a child universe. Our atoms, our information, everything we are redistributed, reorganized, bounced into a new configuration with new laws of physics. You won't survive as you, but the information that defines you will survive, scrambled and remixed into new patterns. In Hinduism, there's a concept called Brahma's day and night. The universe emanates from Brahma, exists for his day, then dissolves back into him at night, only to emanate again the next day. Cycles of creation and destruction, forever. What if that's not mythology? What if it's cosmology? The universe expands from the Big Bang, exists for billions of years, collapses at the singularity, and bounces into a new Big Bang. Eternal inflation and deflation, birth and death, over and over forever. And each cycle might be different. New fundamental constants, new numbers of dimensions, new possibilities for matter and energy and structure. We're in one cycle, one configuration, one roll of the cosmic dice. And when our cycle ends, the dice will be rolled again. Does this make your life meaningless? Does it rob existence of purpose? I don't think so. I think it makes every moment precious beyond measure. You're not permanent, but you're not irrelevant. You're a chapter in a book that's infinitely long. Future chapters won't remember you exactly, but they'll contain themes and ideas and patterns that echo through from your chapter. The universe is learning, evolving, exploring what's possible within the structure of physical law. And you're part of that exploration. Every choice you make, every relationship you form, every idea you have, it's all data in the cosmic experiment. When physicists talk about the anthropic principle, the observation that the universe seems fine-tuned for life, they're often just pointing out the obvious. We exist, therefore the universe must be compatible with our existence. But what if it's more than that? What if universes evolve through natural selection, and life is the mechanism of that evolution? Stars create black holes through natural processes, but intelligent life could create them deliberately with chosen initial conditions. We could guide the evolution of universes, selecting for properties we value: complexity, beauty, consciousness, love. Our descendants, far in the future, might become cosmic gardeners, planting universe seeds, nurturing them with information, watching them grow into new realities. And we're the beginning of that process. You watching this video, learning that you're in a black hole, you're the first generation to see the prison clearly. The first generation with the knowledge needed to understand the escape route. Not escape for yourself. You're locked in, falling toward the singularity at the end of time. But escape for your information, your ideas, your contribution to the cosmic pattern. What you do matters because it determines what information gets encoded into the black holes we'll someday create. Those black holes will become universes, and those universes will inherit patterns from ours. If we build a civilization based on compassion, cooperation, and creativity, those patterns will echo forward into child universes. If we build a civilization based on violence, exploitation, and destruction, those patterns will echo forward instead. We're not just living in the present. We're programming the future. Not our future, the future of universes we'll never see, filled with beings we'll never meet, living under laws of physics we can't imagine. That's your legacy. That's your meaning. That's why your choices matter, even inside a cosmic prison. I know some of you are thinking, this is fascinating speculation, but is there any hard evidence? Any mathematical proof? Let me share with you some equations that will make this entire discussion concrete. Einstein's field equations, the foundation of general relativity, look like this. G equals 8t, the left side, G, describes the curvature of spacetime. The right side, T, describes the matter and energy content. The equation says, matter tells space how to curve, and curved space tells matter how to move. When Carl Schwarzschild solved these equations for a non-rotating black hole in 1916, he found something called the Schwarzschild metric. Inside the event horizon, the time and radial coordinates switch their mathematical roles. The time component becomes space-like, and the radial component becomes time-like. What this means in plain language, inside the event horizon, moving forward in time is like moving inward in space. You can't stop moving forward in time, so you can't stop moving inward in space. The singularity isn't a location, it's a moment, and that moment is in your inevitable future. Now, when Alexander Friedmann solved Einstein's equations for an expanding universe in 1922, he got a different metric, the Friedmann-Lemaître-Robertson-Walker metric. This describes a universe that starts from a singularity, the Big Bang, expands, and depending on its density, might expand forever, or eventually collapse back to another singularity. Here's what blew my mind when I first learned this. The mathematical structure of the FLRW metric inside a black hole and the metric for an expanding universe are nearly identical. They're both describing the same geometry from different perspectives. In 2011, physicist Rzee Porhuizen and collaborators published a paper in Physical Review D, showing that you can mathematically map one onto the other with a coordinate transformation. An expanding universe looks like the interior of a black hole when viewed from the right reference frame. The math doesn't lie. The equations don't care about our intuitions. And the equations say these two scenarios, being inside an expanding universe and being inside a black hole, are two descriptions of the same reality. But there's more. When you calculate the Schwarzschild radius for a black hole with the mass of the observable universe, about 1,053 kilograms, you get roughly 13.7 billion light years. That's eerily close to the age of the universe in light years, 13.8 billion. Coincidence? Maybe. Or maybe it's telling us something profound. The radius of the observable universe and the Schwarzschild radius of a black hole containing that much mass are related because they're measurements of the same structure from inside and outside perspectives. Then there's the holographic principle, which comes from studying black hole thermodynamics. Jacob Bekenstein proved in 1973 that the entropy of a black hole, a measure of information, is proportional to the area of its event horizon, not its volume. S equals kc cubed A for GK, where S is entropy, A is the area of the horizon, and the other symbols are fundamental constants. This equation says that a black hole with an event horizon of 1 square meter can contain a maximum of about 1,069 bits of information. That's not arbitrary. It's the maximum information density possible in our universe. When you calculate the total information content of the observable universe using this formula, you get about 10,120 bits. And guess what? That's encoded on a sphere with a radius of about 46 billion light years, the cosmic horizon. The math is telling us the universe is holographic. You're encoded on a boundary, and that boundary looks suspiciously like an event horizon. Okay, let's get practical. You're inside a black hole. You're falling toward a singularity. You're a holographic projection of information on a cosmic boundary. Your entire existence is a temporary pattern in an eternal information structure. So what? How does this change what you do tomorrow? How does it affect your relationships, your career, your purpose? First, understand that you're not separate from reality. You're not an observer looking at the universe from the outside. You're the universe, locally organized into a structure that can observe itself. Every atom in your body was forged in the core of a star, ejected in a supernova, and reassembled into you. You're made of dead stars, and when you die, you'll become stars again. This means environmentalism isn't about saving something out there. It's about maintaining the stability of the system you're part of. Damaging the biosphere is like a cell damaging the body it's part of. It's self-harm at a planetary scale. Second, recognize that consciousness is the universe's way of knowing itself. Your subjective experience, the feeling of being you, is cosmically important. Not because you're special individually, but because you're an instance of something miraculous. Matter organized in such a way that it can reflect on its own existence. When you look at a sunset and feel awe, that's the universe experiencing the beauty of its own light, scattering through its own atmosphere. When you feel love for another person, that's the universe recognizing itself in another configuration. This means your mental health, your capacity for joy and connection and creativity. These aren't just personal issues. They're cosmic issues. Taking care of your consciousness is taking care of the universe's capacity to experience itself. Third, understand that death is transformation, not annihilation. The information that defines you is encoded in quantum correlations throughout space-time. When your brain stops processing that information, the information doesn't vanish. It disperses, redistributes, becomes part of other patterns. This isn't reincarnation in the religious sense. It's information conservation in the physics sense. You won't remember being you, because you is a specific configuration, and that configuration will dissolve. But the building blocks that made you will persist, rearranged into new forms. This should make you less afraid of death, but more invested in the pattern you're creating while alive. What information are you adding to the cosmic hologram? What patterns are you strengthening? Compassion or cruelty? Creativity or destruction? Connection or isolation? Fourth, realize that your choices create reality, not just for you, but for the entire future light cone of space-time that branches off from your decisions. Every time you make a choice, you're collapsing quantum possibilities into classical facts. You're selecting which branch of the wave function becomes real. In a very literal sense, you're a co-creator of reality. Not in a mystical manifest your destiny way, but in a rigorous quantum mechanical way. Your observations and choices determine which potential realities become actual realities. This gives you enormous responsibility, but also enormous freedom. You're not predetermined. You're not a puppet. You're an active participant in the unfolding of the universe. Fifth, understand that connection is deeper than you think. When you form a relationship with someone romantic, friendship, family, you're creating quantum entanglement between your information structures. Your thoughts literally influence each other through mechanisms we're only beginning to understand. The people you love aren't separate from you. They're entangled with you. Their information is correlated with your information on the cosmic boundary. When they die, they don't leave you completely. The entanglement persists, encoded in your memories and patterns of thought. This is why grief feels like losing a part of yourself. You're not metaphorically losing a part. You're literally experiencing the dissolution of an information structure that was partially shared between you. But it also means that love transcends death. The patterns you created together are encoded permanently in the structure of space-time, preserved in the holographic boundary, carried forward into whatever comes after the singularity. Let's talk about where humanity goes from here. We're inside a black hole. We have, optimistically, trillions of years before reaching the singularity. That's an incomprehensibly long time, long enough for evolution to transform us into something we wouldn't recognize, for technology to advance beyond our wildest dreams, for civilization to spread to every star in the galaxy. But eventually, we'll run out of road. The stars will burn out. Black holes will be the only sources of energy, slowly evaporating through Hawking radiation. And finally, even the black holes will evaporate, leaving nothing but a sea of low-energy photons spreading eternally through expanding space. Unless we figure out how to escape. Remember the wormhole possibility? The idea that quantum entanglement might create tunnels through space-time? That's not science fiction. That's cutting-edge theoretical physics being explored by some of the smartest people alive. In 2021, physicist Leza Randall and collaborators published a paper showing how traversable wormholes could theoretically be constructed using quantum circuits and negative energy. The technology is far beyond us. We'd need to manipulate quantum fields at macroscopic scales, stabilize exotic matter, and solve engineering problems we can't even formulate yet. But far beyond us isn't impossible. It's just difficult. If we survive the next few centuries, the danger zone where civilizations develop world-destroying technology before developing the wisdom to use it responsibly, then we'll have millions of years to work on the problem. And millions of years is a long time. Our descendants might crack it. They might figure out how to create a stable wormhole that punches through the event horizon, connecting our cosmic black hole to the parent universe. Not to escape ourselves, where information patterns evolved for this environment, but to send a signal, a message, proof that we existed. We were here. We figured out where we were. We chose to be remembered. That message would travel through the wormhole, emerge in the parent universe, and be received by whatever civilization or intelligence exists there. And they would know life is possible inside black holes. Consciousness can evolve in cosmic prisons. Intelligence can recognize its own constraints and transcend them. We'd be making first contact not with aliens in our universe, but with the creators or inhabitants of the universe that contains ours. And maybe they'd respond. Maybe they'd send information back through the wormhole knowledge about physics that transcends our universe's laws. Technologies we can't discover because they require parameters we don't have access to, or simply a message of recognition. We see you. You're not alone. This is speculation, of course. We don't know if it's possible. We don't even know if there is a parent universe. Maybe it's black holes all the way up with no base reality. Just an infinite tower of nested spaces. But the possibility exists. And as long as the possibility exists, it's worth pursuing. Because the alternative is accepting our prison without question, living out our cosmic sentence, and disappearing into the singularity without leaving a trace beyond our local cosmic horizon. And humans don't accept prisons. We climb mountains because they're there. We explore oceans because they're deep. We go to space because it's hard. We would absolutely try to escape a black hole if we knew we were in one. Which brings me to the real reason I made this video, the real message I want you to carry forward. Now that you know, now that you understand where you are, what you are, and what constraints you're operating under, you have a choice. You can despair. You can see the cosmic prison as proof that nothing matters, that we're trapped, that existence is pointless. Or you can do what humans have always done when confronted with constraints. Push against them. Test the boundaries. Look for weaknesses in the walls. The physicists working on quantum gravity, on wormhole physics, on the holographic principle, they're not just doing abstract mathematics. They're mapping the prison. They're finding the weak points. They're drafting the escape plan. And you can contribute. Not necessarily by becoming a physicist, though we need those, but by maintaining a civilization that's capable of supporting long-term fundamental research, by building institutions that persist across centuries, by raising children who ask dangerous questions, by creating art that inspires wonder about the nature of reality, by building technologies that expand our capabilities, by fostering the cooperation and wisdom needed to survive long enough to crack the cosmic code. Every act of creativity, every moment of teaching, every instance of choosing cooperation over conflict, these are contributions to the project of cosmic escape. Not escape for you personally, but escape for the information lineage you're a part of. You're not going to solve the black hole problem in your lifetime, but you might raise someone who raises someone who raises someone who does. That's how multi-generational projects work. Cathedrals take centuries to build. Civilizational projects take millennia. Escaping a black hole might take millions of years. But every journey starts with someone taking the first step. And you're taking it right now by understanding where you are. There's one possibility we haven't fully explored yet, and it's the most unsettling one. What if the black hole we're inside wasn't natural? What if it was engineered? Think about what it would take to create a black hole with specific properties, controlled mass, rotation, charge, and most importantly, controlled initial quantum conditions. A civilization advanced enough could theoretically collapse matter in a precise way that determines the laws of physics in the resulting universe. They could fine-tune the constants. They could select for properties that produce interesting results. Stars that last billions of years. Chemistry that supports complex molecules. Gravity that's strong enough to create structure, but weak enough to allow large-scale stability. They could create us. Not as a simulation running on a computer, but as a physical universe with real physics, real matter, real consciousness. We wouldn't be less real than them. We'd be differently real, existing in a different reference frame, but experiencing genuine existence nonetheless. Why would they do this? One possibility: scientific research. They want to understand how life evolves, how consciousness emerges, how civilizations develop. They can't run the experiment in their own universe. It would take too long, or it might be dangerous. So they create a black hole universe, set the initial conditions, and watch what happens. From their perspective, our entire 13.8 billion year history might happen in seconds due to time dilation. They could observe millions or billions of universe experiments, each with slightly different parameters, and study the results. We'd be lab rats in the most literal sense possible, not because they're cruel, but because we're the only way they can answer certain questions about reality. Another possibility: art. Creating a universe might be the ultimate creative act. They're not watching us for scientific data. They're experiencing us aesthetically, the way you might watch a movie or read a book. Our joys and sufferings, our triumphs and failures, our entire history. It's all a story being told in the language of physics. You're not an audience member. You're a character. And the author isn't writing your lines. They set up the rules of grammar and let the story tell itself. A third possibility, darker and more profound. They're dying, and we're their afterlife. Imagine a civilization facing the heat death of their universe. All the stars are gone. All the black holes have evaporated. Entropy has maximized. Nothing new can happen. No information can be processed. They're facing eternal stasis existence without experience, consciousness frozen in a single unchanging state. But before they die, they encode themselves into a black hole. All their knowledge, all their history, all their culture compressed into quantum information that will bounce and become a new Big Bang. They won't survive as themselves, but fragments of them will echo through the new universe. Physical constants that make their kind of chemistry possible. Patterns in the cosmic microwave background that contain encoded messages. Mathematical truths that any sufficiently advanced civilization will discover, bringing them closer to the creators. We might be their descendants. Not genetically, that doesn't cross universe boundaries, but informationally. The structure of reality we inhabit might be shaped by the dying thoughts of a cosmic predecessor. In religious terms, we'd call this God, a creator who existed before our universe, who encoded information into our existence, but who doesn't intervene directly because they died in the process of creating us. In physics terms, it's just information conservation across a black hole event horizon. The mathematics doesn't care about our emotional reactions to it, but I care about your emotional reaction. Because this realization should fundamentally change how you think about legacy and meaning. If the creators died to make us, then we owe them something. Not worship. They're not gods demanding obedience. Not even gratitude necessarily. They didn't ask our permission to exist. But we owe them continuation. We owe them the effort to preserve and extend the information lineage. To learn, to grow, to understand, to create, and eventually to pass it forward by encoding ourselves into black holes that will become new universes. We're not the end of the chain. We're a link, and the chain must not break. We've covered a lot of ground. Let me bring it all together. You are inside a black hole, not metaphorically, not maybe. The mathematics of general relativity, the observations of cosmic expansion, the structure of the cosmic microwave background, the existence of dark matter and dark energy, all of it points to the same conclusion. Our universe is the interior of a massive black hole in a parent universe. This isn't fringe speculation. This is serious physics, explored by Nobel Prize winners and published in peer-reviewed journals. The evidence is circumstantial, but compelling. And more importantly, the hypothesis is testable. We can look for signatures in cosmological data that would confirm or rule it out. What does this mean for you? First, scale. You're part of something infinitely larger than you imagined. Not just a planet, not just a galaxy, not just a universe, but a nested hierarchy of universes, each containing the others, extending up and down through dimensions of reality we can barely comprehend. Second, time. You're not living in a static moment. You're falling through space-time toward the end of time itself. Every second you experience is 300,000 kilometers of travel through the four-dimensional fabric of reality. You're moving at the speed of light through the temporal dimension, and nothing can stop you. Third, information. You're not just matter and energy. You're a pattern of information encoded holographically on the cosmic event horizon. Your thoughts, your memories, your identity, all of it exists simultaneously as neurons firing in your skull and as quantum correlations on a boundary 46 billion light years away. Fourth, connection. You're not separate from other people, other life, other structures. You're all expressions of the same underlying information field, temporarily organized into distinct patterns, but fundamentally united at the deepest level of reality. Fifth, impermanence. You will die. Your pattern will dissolve. The information that defines you will disperse. But it won't be destroyed. It will be redistributed, encoded in Hawking radiation, preserved in the cosmic hologram, and eventually transmitted beyond the event horizon when the black hole evaporates. Sixth, legacy. What you do matters because you're adding information to the cosmic pattern. The choices you make, the relationships you form, the ideas you generate, these become part of the structure of reality itself, persisting long after your local pattern dissolves. Seventh, hope. You're in a prison, yes, but it's not an absolute prison. The laws of physics allow for quantum tunneling, wormholes, information escape. It might take 1,000,000 years or 1,000,000,000, but if humanity survives and grows and learns, we might find the crack in the cosmic cage. Eighth, responsibility. If we're descendants of a civilization that encoded themselves into a black hole, then we're carrying their legacy. And we have the opportunity, maybe the obligation to continue the chain by encoding ourselves into black holes that will become new universes. You're not just living a life. You're participating in cosmic reproduction. You're part of how reality perpetuates itself across the boundary of possible existence. Now, I know some of you are thinking, this is beautiful and terrifying, but is it true? How confident should I be in this hypothesis? Here's my honest answer. I don't know. Nobody knows. The evidence is suggestive, but not conclusive. There are alternative explanations for everything I've described. Standard cosmology works without requiring the black hole hypothesis. But here's what I'm certain of. The question is worth asking. The possibility is worth exploring. And the implications, if true, are so profound that even a small probability of correctness demands serious attention. Pascal's wager, but for cosmology. If there's even a 1% chance we're in a black hole, shouldn't we be investigating that possibility with everything we've got? Because if it's true, it changes everything. Our understanding of time, space, consciousness, death, meaning, purpose, all of it needs to be rebuilt from the ground up. And if it's false, if we investigate thoroughly and conclude definitively that we're not in a black hole, then we've learned something important about the structure of reality. We've tested the limits of our observational and theoretical tools, and we've proved that some boundaries can't be crossed even in principle. Either way, we win. Either way, we understand more. That's what science is. That's what being human is. Asking dangerous questions, testing impossible hypotheses, pushing against the boundaries of knowledge until they either break or push back. So here's what I want you to do after this video ends. First, sit with this information. Don't immediately accept or reject it. Let it percolate. Think about what it would mean if it's true. Think about what it would mean if it's false. Notice how it changes your perspective on your daily life, your relationships, your fears, your hopes. Second, learn more. I've given you names: Nikodem Poplawski, Lee Smolin, Roger Penrose, Leonard Susskind, Stephen Hawking, Juan Maldacena. Look up their papers. Read their books. Follow the citations. Build your own understanding from primary sources, not just from videos like this. Third, talk about it. Have conversations with friends, family, strangers online. Explain the hypothesis in your own words. Debate it, defend it, and attack it. See what holds up under scrutiny and what falls apart. Collective intelligence is how we sort truth from fiction. Fourth, stay curious. This isn't the only mystery in physics. Quantum mechanics is weird. Consciousness is unexplained. The measurement problem is unsolved. The nature of time is contested. Dark matter and dark energy are still mysterious, even if they're not what I've described here. Reality is far stranger than our intuitions suggest. Every time we think we've figured it out, we discover a new layer of weirdness underneath. That's not a bug. That's a feature. That's what makes existence interesting. Fifth, take care of yourself and others. Regardless of whether we're in a black hole, you're conscious. You can experience joy and suffering. So can everyone around you. That's the irreducible moral fact at the center of existence. If we're all temporary patterns in an eternal information field, then every moment of genuine connection, every time you make someone laugh, every time you ease someone's suffering, every time you create something beautiful, that's you adding positive information to the cosmic hologram. You can't control how long you exist, but you can control what pattern you create while you're here. Sixth, think long term. If this hypothesis is true, then humanity's story is just beginning. We're 13.8 billion years into a journey that might last trillions of years. We're not even 1% of the way through. The decisions we make now about climate change, about artificial intelligence, about nuclear weapons, about social cooperation, will ripple forward through all that time. We're not just deciding our fate. We're deciding the fate of countless generations who might live, might spread to the stars, might crack the code of cosmic escape. Live as if the future matters, because it does. Seventh, embrace uncertainty. You will never have perfect knowledge. You will always be acting on incomplete information. That's the nature of being inside a system, trying to understand the system from within. But uncertainty isn't paralysis. You can make good decisions without certainty. You can commit to values, build relationships, pursue goals, and create meaning, even while acknowledging that you might be wrong about fundamental things. In fact, that's the only way to live authentically. Anyone who claims perfect certainty is either lying or self-deceived. The honest position is, I don't know for sure, but based on available evidence and my values, here's what I'm going to do. Eighth, create. Write stories. Make art. Compose music. Build technologies. Have children and raise them well. Start businesses. Plant trees. Do research. Teach. Whatever form your creativity takes, do it. Because creation is how information propagates. It's how patterns persist. It's how meaning spreads through time. You're going to die, but your creations, physical, intellectual, relational, will outlive you. They'll influence people you never meet, in times you'll never see, in ways you can't predict. That's your shot at immortality. Not living forever, but creating patterns that echo forward, influencing the trajectory of the cosmic story in some small way. We've been on this journey together for over 4 hours now. If you've made it this far, thank you. Seriously, in a world of infinite distractions, you chose to spend 4 hours contemplating the deepest questions about existence. That matters. Let me leave you with one final thought. Whether or not we're in a black hole, whether or not the holographic principle is true, whether or not universes nest infinitely inside black holes, one thing is certain: you exist. Right now, in this moment, you have subjective experience. You see colors, you hear sounds, you feel emotions, you think thoughts. Whatever the underlying structure of reality might be, your consciousness is real to you. And that's the only kind of real that ultimately matters. Descartes was right about at least one thing: I think, therefore I am.